Alrighty, welcome everyone to day 14 of Advent Code. 30 seconds data for the puzzle is released. I did go ahead and make a visualization for yesterday, day 13. Really all it is just re-outputting your inputs, but adding the reflection line in the little green line here. And the reflection lines, you can kind of see it, mainly used for debugging if you want it, part 1 and part 2. So not too much to visualize, but if you're having trouble with it, need a little debug to kind of help see where the lines are, this can help you out. But at any rate, day 14, let's get it. You reach a place where all the mirrors were pointing a massive parabolic reflector dish attached to the side of another large mountain. The dish is made up of many small mirrors, but while the mirrors themselves are roughly in the same of the shape of the parabolic reflecting dish, each individual mirror seems to be pointing in slightly the wrong direction. If the dish is meant to focus light, all it's doing right now is sending it to a vague direction. This system must be what provides energy for the lava. If you focus the reflector dish, maybe you can go where it's pointing and use the light to fix the lava production. Upon closer inspection, the individual mirrors each appear to be connected via an elaborate system of ropes and pulleys to a large metal platform below the dish. The platform is covered in large rocks of various shapes depending on the position. The weight of the rocks perform the platform okay. If you move the rocks, you can focus the dish. The platform, even a control panel on the side, lets you tilt in one of the 4 directions. The round rocks 0 will roll when the platform is tilted, while the cube-shaped rocks will stay in place. You know if the position's empty as that. By tilting levers, so all the rocks will slide as far north as they will go. Notice the support beams on the north side of the platform are damaged. To ensure the platform doesn't collapse, you should calculate the total load on the north support beams. The amount of load caused by a single round rock 0 is equal to the number of rows from the rock to the south edge. Is 136. Tilt the platform so all the rocks roll as far northward. Afterward, what is the total load on the north support beams? I'm gonna guess part 2 is gonna be some sort of they're gonna be moving around. So I can think about it, but I'm not sure I'm gonna be able to plan for that. So as always, let's just take our inputs, map or split it first into new lines, and then map and split those into individual characters. Cool. So now we have our grid. So I'm actually going to const grid. I'm actually going to go ahead and make a method here called const tilt up. I think it's north. Actually, we'll call it north. Tilt north. That's going to take in the grid. And we'll return a grid. Sure. Okay. So actually the grid is that type. So what's going to happen is we need to go from top to bottom and shift everything up. So grid, map, yeah, grid maps here is a row. And then we're gonna have to do return row dot map character. Yeah. What's this complaining about? There we go. So what's going to happen is we're going to need row and Y, C, and X. So if the character is this. I'm going to do this to where we're going to pull things up. So as we go through it, we're going to pull what's below up. So if it is, actually if it's this, we're just going to return the C. If it is rock, round rock, we're not going to do anything, because in theory, by the time it gets here, it shouldn't be moving anywhere. So we really only care about this, which I'm realizing is just this. All right. So if we get this, what we're going to have to do is we're going to have to grid find index where R of X equals around rock. Const rock index, and then if the rock index equals -1, return C, because there's nothing to move. Otherwise, we're going to go ahead and do grid of rock index X equals empty air, and we will return the rolling rock. Which actually we're returning C. No, not returning C. Return the rolling rock. Which just means we can now call tilt north on the grid, and then reduce. This is going to be row y. All right, sorry. This means sum row, and we're gonna have to call the return sum plus row map. I do need y on that, not map. Reduce row sum column that. Okay. So all that's left is now to count them up. And what was the amount of load caused by a single rock 0 is equal to the number of rows from the rock to the south edge. So 1, 2, 3, 4, 5, 6, 7, 8. So it's 9. So it's gonna be so starting at 0, so it would be the length minus index plus 1. So we're gonna have to return row sum plus, and it's gonna be cell equals this, otherwise 0. But if it is that, it's gonna be y. No, it's gonna be grid dot length minus y minus y plus 1. And cons part 1. In theory, I think that's all we need. We're gonna send this. I don't know if this adding logic's correct. We got 0, so nope. Nice. I never saved it. Nice. No, okay. I'm gonna assume my logic on the adding is incorrect. Something is up with it. 341. It's 136. Oh no. Oh, I'm going all the way through. Okay, find by index, right. What I need to do is I need to find, I also need to find the block index. Because if there's a block, or block index is less than, oh, we're also, grid, slice, y. This way it can't, grab it. And then, or block index is less than rock index. Alright, that should also address it. 182. Progress. Let's see how this grid looks. Oh. I'm close, but I'm missing 3 rocks. Ah. This and block index does not equal -1. 266. Alrighty. First line looks right. Second line. Huh. Second line, though, shouldn't look like that. I've got stuff on the very last line, which is also not correct. Alright, I'm gonna style output this a bit more. Yeah. Row join on, do that. I don't know why I did map. Yeah, that does not look, that does not look right. Something looks off there. My grid's correct, right? Yeah, it's my initial grid. Looks right. I don't know where all these zeros came from. Plus y. That does not help at all. Wait, that does not help. Sorry. Plus y. Where is it finding? It's just like finding random rocks. I think the first line is correct. What is going on? Oh my goodness, I'm doing... Right. It's because this whole grid is a bunch of read-only, read-only. Yeah. Okay, I'm gonna just turn this off for this file. Right. I don't know how that made it through me looking at it, but it somehow did. Disable for the file. Okay. 118. All right. Progress is made. That looks right, which means that there's no +1 on this. It's just that. Oh, I had that, and I just, you know, freaking logic there. It's input. So close, yet so far. There we go. Nice and easy. It was much easier than I made it out to be, but alright. Purple focus deforms, but not in a way that focuses the beam. To do that, you need to move the rocks to the edges of the platform, for which you have a button on the side. Spin cycle attempts to do just that. Each cycle tilts the platform 4 times so that all the round rocks roll north, then west, then south, then east. Round rocks roll as far as they can before the platform tilts the next direction. After one cycle, the platform will have finished rolling the rocks. Okay. Okay, the process should work if they're running long enough after... That's a lot of cycles. I figured this was going to happen. I figured I was going to have to do a tilt north. South. South's going to be... Oh no, but this was the easiest to do. It's going to be... Find index. Is it just find last index? So find the last index of the rock. Find last... No, but it's not find... Well, actually, it would be find last. It was just going to go from 0 to y. Yeah, so it's got to be above. So in theory, a rock can just kind of fall down. What if I flip this? What if I do const y, make this yy? What if I do grid dot length -1 minus yy? Now this is going to go reverse. And so it's going to find those two. So now I need to find the rock in the row. The rock index is -1. We don't care. If the block index is greater than the rock in this case, we don't care. Is there anything else we don't care about? Rock index is -1. We didn't find one. Block index is after the rock. That means a block blocks this. Sorry. I think we're good there. So we need const cycle. Goodness. And so all it's going to do is just going to be doing tilt north. Tilt north, tilt south. Return grid. Okay. Okay, and so we call it cycle on this. Oh, no, that's just tilt north, still tilt north. Part 2 is going to be cycle, give it grid. So we don't change grid, right? We do map it. But we're returning that map. Okay. But we edited it there. Dang it. Fine. Grid 2. Okay, so then it's going to be run a cycle, and that is good. So now we just need a tilt east, which is going to the right. Which means... What does that mean? What does that mean? Is east more like north or south? It's going to be more like south, which is the one I copied. Good. So instead of grid slice Y, we are going to just do row slice X, row slice X, find index. We don't need that there. And that all works. That's going to be rock index plus X. Sweet. So what's the order? It goes northwest, southeast. Nice. Okay, north. I believe that's all it is, because it's going to the right. And so north, that's going to be west, again, like this. So it's going to be row, slice, X, X, that. This gets bumped to there. Grid. Is that all? So that's one cycle. So in theory, Y is less than. Actually, I'm just copying this. I don't know why I'm going to try and do that out like that. In theory, this is the brute force, which should be realistically impossible. And then but just for laughs, I'm going to try it and do a console log I for laughs. Ah, it doesn't even work. Nice. Oh, right. The find last index of bit again. Hold on one second. Sorry. Yeah, last index of it's. I'm using node 16. It's apparently in node 18. So I have to actually write my own. Oops, not this way. Nope. Find last index. Did I not copy find last index? I thought I copied this one. Because south is more like east. I was pretty sure I'd copied this one for east. Apparently I didn't. Apparently I was, I don't know, going crazy when I said that. So let's fix that. I don't need to do this. What I do need to do is y, and this is x, 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 x. This is going to be row dot length. Okay, and then all these need to be addressed and changed to one I made. Because and so I guarantee there's gonna be some sort of find a pattern here. I'm pretty sure, I'm just for fun I'm doing this, just to see what how far it gets, but also make sure it actually works. Gotta set properties of undefined. Setting 1. Grid dot map. 2. One. Wait, what? Huh? Is it because it's trying to set? No, it shouldn't matter like that. Not set properties of undefined. What's it trying to set? One. Or I set in of 1. Oh, it's not rock index plus y. It's gonna be straight up rock index because I'm not. Yeah. Right. So that means east or no, west. Well, also no east because it's plus. This one's the same. That one has the same problem. Beautiful. And see, that is why this won't work, because it's not slow, but I'm not getting to 1 billion. So that's where we need to figure out where the cycle comes through. I'm gonna do this 10 times. I'm just going to do grid 2 equals that. Sorry, that. And we're gonna do for each row console log row dot join, and before we do it each time, output this just so we get kind of breaks and new lines and stuff. So, what I need to do is I want to use test. All right. What are we getting here? What are we getting here? Does it change? It does. So it's after 1 cycle, it's changing. Three cycles. Wait, what? North, west, south, and east. north, west, south, and east. Something's not right. My south cycle not work? I wonder if my south cycle doesn't work. Do this. One of these must not work. Grid. West, south, east. All right. What's going on here? What ain't working? What? Okay, we're good here. Okay. So that is north. Right? Looks about right. Okay, so it's north. And then after north is west, I said. So it's going to be left. Which looks right. Oh. So south and east are not working. Sorry. South. What's going on in the south here? What is going on with south? So it's not changing the rock. So we're going from 0 to Y. We're finding the rock we want. Rock index, find less index. If the block index is greater than the rock index, we don't want to move it. The fact that it's something that shouldn't matter because we're still just doing it normally. Oh, it's because we are returning and building it up. Alright. So we can't do it reversed. Okay. Which shouldn't be a problem, because it's just gonna move it one by one. But it's not gonna grab them correctly, though. Yeah, it's not gonna grab them correctly. So what if I did do a reverse and then a reverse again? What if I double reverse it? Will that make the south work? North. No. Because if I reversed it. Oh, but if I reverse it, I gotta do the whole logic. I mean, honestly, it's just north again. It's the exact same logic as north. Right? Okay, so let's do the same thing here. We can just do row reverse, map it, and then reverse it back. That way we can use the exact same logic. Sorry, not this one. This one, that we can use the exact same logic as here. And so after one cycle, you shouldn't see anything down there. That's north, west, oh. Wait, they just somehow they just teleported through. The heck? Wait, it's working, just the east doesn't work right. The east they just teleported through. Huh? How did those just like straight up teleport through those rocks? Wait a minute, what? They're all in the same way. Oh. That's why. Hey, okay. Now we're in business. Okay. Alrighty. Whoops. Now we're looking good. So we can run our cycles now. And in theory, we are losing circles somehow. What? How am I losing circles? They just disappear. Huh? Oh, because I'm passing the wrong thing through. That'd be why. Okay. So what we're gonna have to do is cache equals this. Map. Just build this into one big string. And then if cache includes temp API, sure. Else cache push temp. Goodness, typing hard. There. Oh, well, it'd be helpful if I did I instead. Let's just do 100. Okay. Okay, let's do this. As string is that as that. Okay, and so we can do is nope. JK. How about that? Because now it's not that. Now we can just do this. Otherwise, cache of temp equals I. All right, get rid of that, but so 2 to 9, 3 to that, so it's 7. So technically it's like every 7 it repeats. So we find the first repeat and pray. Okay. So if we have a repeat, that means the logic would be I minus that. That's how much it is. It'd be we just need the index. We just need the index. We need the step. The step of the one we're trying to find. So we would do what we're trying to find minus the start with the remainder of that. And that gives us const step, and then we just do object keys how about this? Object keys of cache find trying to like parse this in my head as I'm going. Find this is also going to change. It's not going to be, it's going to be step. And I'm also going to need to hold the grid. Make my life easier. Cache that, okay, equals step is I, and the grid is the grid. Step. Find C, cache C step equals step. And then we're gonna log part 2 is gonna be cache key grid. Return. Or break. That should match up to that, which it doesn't. Good. Okay, ended up going to Reddit for a little bit of help. Found someone who had done something very similar to me, but what they actually did is instead of having the calculation here, they actually just incremented their I to go to where the cycle would have been, basically around this number, or kind of where it would have been, and then it continue on for that last little bit to get to the end value and then output it. So I did that, cleaned this code a bit. I didn't bother with what's up here. So it's not slow, but it's not exactly fast. But yeah, there we go. Both parts are complete. So thank you to that person for just giving me that last little bit to, you know, it was so close, just math. But at any rate, day 14. The tilts are pretty self-explanatory. There, I did see some other people who did some better, but all mine is for the north, south, east, and west are all very similar. The opposites, north and south, are the same, except I reverse the row or the column depending on which one it is, and then reverse it back. That way, this logic works. But for the tilt, all I do is I go through every row and column, and I find on the empty space, or on the empty cells denoted by a period, we find the rock index and the nearest rock and the nearest block index, and assuming that there is a rock in that row or column with this, that is before, or that comes before the cell we're at, or so the row or column or whatever, assuming there is one, and assuming that it is also before or is after, I guess, assuming it's after any blocks, so there's no blocks between the rock and where we're at. We simply just, you know, we update this cell to have a rolling rock and set the old cell to be empty, and that's really all it is here. Just kind of moving those there. The south, they're all the same. The west and east are the same, just you're using the column instead of the row. And like I said, I reverse these and flip them back. That way the logic's a little bit easier to work with. Cycles, pretty self-explanatory. Load values, pretty self-explanatory. Just two reduces with some slight logic for calculation. And part one's easy because part one's just one tilt and the calculation. Part two is the cycle, and then the last bit, which I struggled with, which was once you find the cycle, or sorry, once you find the pattern, the cycling pattern from the cycles, you can jump ahead to the end. In my case, jump ahead to the end where this cycle would pick up as it nears the 1 billion mark, and then do the last 100 or so steps in that cycle or whatever, and then that gives you your answer when it finishes. So that's how I did it. We'll see how this goes, but thank you guys for being here. See you guys tomorrow for day 15. Peace out.